Section 12.3, day number 2. As I said in class, today is going to be focused on dividing polynomials with a remainder. Okay. So here we are again. Just a quick review. Long division: 11 goes into 15 one times. 1 times 11 is 11. Subtract those, you get 4. You bring down everything else. 4, 6, 8, 4. 11 goes into 46. 4 times 11 is 44. Subtract, you get 2, 8, 4, get carried down. Alright, 11 goes into 28 twice. 2 times 11 is 22. That's 6, bring down the 4. 11 goes into 64 5 times. 5 times 11 is 55. Subtract, you get 9. 11 does not go into 9, so the answer here would be 1,425. Remainder 9. Okay, so there's 9 left over. Alright, so when we look at this first expression here, we want to divide. Again, we're going to start it just like we would any other division problem. So 2x plus 3 goes into 2x squared plus 9x minus 6. Okay, and so 2x goes into 2x squared, x times 2x is 2x squared, x times positive 3 is positive 3x. Subtract, 2x squared minus 2x squared cancels, 9x minus 3x is 6x minus 6. Alright, bring this guy down. That's where the minus 6 came from. 2x goes into 6x positive 3 times. 3 times 2x is 6x. 3 times 3 is positive 9. Subtract. 6x minus 6x is 0. Negative 6 minus 9 is negative 15. And obviously 2x does not go into negative 15, so your remainder here is negative 15. Okay, now here's the difference. When we have a remainder, okay, when we're dividing polynomials, we're not just going to write our negative 15 up here. Okay, we're actually going to go ahead and put plus, and then you put your remainder on top of your divisor. And so that right there would be our final answer. Okay, x plus 3 plus negative 15 over 2x plus 3. Okay, kind of goofy, but still, that's how we handle a remainder here when we talk about dividing polynomials. Now, the way you check this, we went over this briefly in class, but the way you would check it is the same way. So you take your quotient, you multiply it by the 2x plus 3. Alright, and really what you're going to do at the end here is just add your remainder or subtract it and just make sure that you get the right spot. So x times 2x is 2x squared, x and 3, positive 3x, 3 and 2x is positive 6x, 3 and 3 is positive 9, 2x squared plus 9x plus 9, and then we take this negative 15 and subtract that on the end. So I actually get 2x squared plus 9x, and then 9 minus 15 is negative 6. And so that guy right there should match up with that guy there, and it does. And so now I know I did it correctly. And again, my final quotient, though, is this whole thing. Okay, so you can't just say x plus 3 remainder negative 15. You got to say x plus 3 plus negative 15 over 2x plus 3. Okay. Alright, we'll talk more about that as we go through. Okay, part B, again, there's just a bunch of examples here, so at any point just pause the video, work through it on your own, make sure you got it. Okay, so x plus 1 is dividing into 3x squared plus 2x plus 2. X goes into 3x squared 3x times. Multiply it by both terms. 3x and x makes 3x squared. Oops. 3x and 1 makes positive 3x. Subtract. Cancel. 2x minus 3x is negative x. Bring down the 2. X goes into negative x, negative 1 times, multiply, negative x, negative 1 times positive 1 is negative 1. So negative x minus x is 0, and 2 minus negative 1 is positive 3. So 3 is your remainder, so you do plus 3 over x plus 1. And so that's our quotient, or at least we think it's our quotient. And so again, what we'll do is we'll multiply our answer times our divisor, so x plus 1. Not real sure why that's not showing up. There we go. X plus 1 times 3x minus 1, and then what you can get in the habit of doing is just adding that remainder on at the end there right away. That's fine. X and 3x makes 3x squared. X and negative 1 makes negative x plus 3x minus 1 plus 3. 3x squared plus 2x plus 2, and we're hoping that this guy matches up with that guy, and it does, so that's a good thing. That means that this is correct. Alright, I'm going to rewrite this a little bit bigger here on the screen so that I can work with it easier. So 2x plus 7, 2x plus 7 divides into 6x squared plus 31x plus 41. Okay, so 2x goes into 6x squared 3x times. 3x, that's 6x squared. 3x times 7 is plus 21x. Subtract. Cancel. 31x minus 21x is 10x. Bring down the 41. 2x goes into 10x 5 times. 5 times 2x is 10x. 5 times 7 is positive 35. Subtract. 10x minus 10x is 0. 41 minus 35 is 6. So remainder is 6. So 6 over 2x plus 7. So we're thinking that's our final answer. But again, we got to go through and check, make sure that's right. So take your divisor, 2x plus 7. Multiply that by your quotient, 3x plus 5. And add your remainder on at the end. So we get 6x squared plus 10x plus 21x plus 35 plus 6, 6x squared, 31x, and 41. This guy should be the same as that guy. It is, so that tells us that answer is correct. Alright, so again, I'm just plugging through examples here. I'm not going to do a whole lot of explaining from here on out. I did that in example 1. You guys can kind of just use these last couple examples to make sure that you have this stuff down. So I don't have to rewrite these polynomials in order, but what I do have to do is, you'll notice here, I'm going to have to add in the x in the middle. So I'd have 8x squared plus 0x plus 3 divided by 2x minus 1. And so now you have 2x minus 1 divides into 8x squared plus 0x plus 3, and then you just plug away here. 2x, 8x squared is 4x. 4x, 2x is 8x squared. 4x negative 1 is negative 4x. Subtract. 0 minus, those cancel. And then we have 0 minus negative 4x, which is positive 4x, plus 3. 2x goes into 4x 2 times. 2 times 2x is 4x. 2 times negative 1 is negative 2. Subtract. 4x minus 4x is 0. 3 minus negative 2x plus is a 5. So 5 is your remainder. So you have 5 over 2x minus 1. Alright, so this would be our final answer here. And again, we're just going to go ahead and take the time to double check that to make sure we're right. So divisor times quotient plus remainder. 4x is 8x squared. 2x plus 2 is 4x. Minus 4x minus 2 minus 5. That's actually a plus 5. I'm sorry. Plus 5. Okay. 8x squared. 4x, negative 4x cancel. Negative 2 plus 5 is plus 3. Hopefully that is the same as that. It is. So we're good to go. Alright. Same idea. So we have 2x minus 5 goes into 12x squared plus 0x minus 7. 12x squared, 6x. 12x squared minus 30x. Cancel. 0x minus negative 30x is positive 30x minus 7. 2x goes into 30x 15 times. So that's 30x. And then 15 times negative 5 is negative 75. Subtract them. 30x minus 30x is 0. Negative 7 plus 75 is going to be a positive 68. So our remainder is 68. Let's see here, 60. There we go. 60. Oh, come on. Sorry about that. 68. Well, you understand what I'm doing here. It should be 68. There we go. 68 over 2x minus 5. Sorry, that's kind of condensed up there, but you get the idea. Alright, so that's what we're thinking our final answer is. Again, let's go ahead and check that thing to verify. So we have divisor times quotient plus remainder. FOIL this out. 12x squared plus 30x minus 30x minus 75 plus 68. So 12x squared, 30x minus 30x is 0. Negative 78 plus 68 is going to be negative 7. So hopefully that is the same as that, which it is. So we're good to go. Check. Got it right. Alright. Kind of redundant here. Again, same idea, just plugging away. Now you'll notice here in this first part, we're going to have to rewrite that. We talked about that a little bit in class. So 3x plus 1 divides into 6x squared plus 11x plus 5. And now I go ahead and divide. So I have 2x, 6x squared plus 2x. Subtract them, cancels 11x minus 2x is 9x. Bring down the positive 5. 3x goes into 9x. 3 times 3 times 3x is 9x. 3 times 1 is 3. Subtract, cancel, 5 minus 3 is 2. So on the end here I have 2 over 3x plus 1. And again, just like we've done every other example, we're going to go ahead and check this thing. So I have 3x plus 1 times 2x plus 3 plus 2. FOIL it out. 6x squared plus 9x plus 2x plus 3 plus 2. 6x squared plus 11x plus 5. Hopefully that is the same as that. Which it is, just different orders. So we're good. Alright, so that pretty much is 12-3. Okay, I know we broke it apart into 2 days, so hopefully that made things a little bit easier for you. Any questions you have regarding remainders, be ready to have those in class tomorrow, and we'll